quite easily distinguished from Western flower thrips or onion thrips. Both of the females anyway are much darker, and they have these pale wing bases that look like, I always think like they've got pale shoulders, and that's quite easily seen with a hand lens, so you should be able to recognise them quite easily. Claire? Next. So I'm going to focus on Thripsitosis this morning because we haven't got a lot of time. Now, this species is native to Japan and Southeast Asia, but in recent years has spread to Northern Europe, including France, Germany, the Netherlands, Belgium, and ourselves. And in the UK, it's been mainly found on the south coast, but it's also popped up elsewhere as well. It's been mainly a problem on cyclamen and New Guinean patiens, but it's also been seen on hydrangea, poinsettia, primrose, begonia, and some protected herbs, including basil and rosemary. Elsewhere, it's been recorded on a very wide range of ornamentals and also on some edibles, including bean and some protected crops like cucumber, pepper, and tomato. It's also been found on certain weeds, including nettle and hogweed. So here we have the adult female. The male is actually a bit smaller and yellow and looks a little bit like Western flower thrips males actually, but the female's very distinctive. You can see the little dark thrips stand out quite well on that white cyclamen flower. Next. So the damage on the underside of the leaves is very similar to that by Western flower thrips. You get this silvering on the base of the leaves and the little black specks, which are the thrips droppings. On cyclamen, that develops into a sort of quite a severe brown scarring on the base of the underside of the leaves. And Neil Hellier from Fargo sent me that picture of the yellow patches on the leaves, which he thought might be tomato spotted wilt virus, because this species, like Western flower thrips, can transmit tosper viruses. Now, Neil never got that confirmed, so we can't be sure that was virus, but I would say if you're seeing any suspect virus symptoms on the plants and you've got this species on the nursery, do get them checked out for virus. And that bottom right picture of botrytis on cyclamen, one of the growers who's had problems with Thripsitosis told me that he's seen that the damage seems to predispose cyclamen to infection with botrytis. Next. It can cause flower damage as well. That middle photograph, you can see some scarring on the base of the cyclamen leaves, particularly where the petals overlap. And the picture on the right is a picture of Vanderthrips damage on Phalaenopsis. Next. So here we have the adult females. I was hoping to show you a video now actually that a grower very kindly sent me of these female Thripsitosis wandering about on a cyclamen leaf. But we're hoping to get that video to work in the lunchtime discussion session. So if you'd like to join us then, hopefully we can get it to work then. Next. So when we're planning control of any pest and including any species of thrips, it's really important to know quite a lot about its biology and behaviour and its different life stages. And that's because we can target different life stages with different control measures. For example, these are all life stages of Western flower thrips, and Thripsitosis has similar ones really. So here we have the adult female. Then we have the small first stage larva, that's the stage that hatches out from the eggs. Then we have the larger yellow coloured second stage larvae. And in Western flower thrips, in most conditions, most of those larvae drop to the ground to pupate. And there's two pupal stages, the prepupa and the pupa. Now, when we're planning control, for example, many of you will be using Neosulus cucumeris, the predatory mite for thrips control. Now, that only eats the first stage larvae. It doesn't eat the second stage and it doesn't eat the adults. Despite that, it can do a good job in maintaining Western flower thrips control. But I'd like you to bear that in mind when we're thinking about Thripsitosis control. Next slide, please. So, on the far left there, you've got Neosulus cucumeris, the predatory mite. Now, On those nurseries where growers have got thripsitosis, they've been finding that cucumeris is giving good control of western flower thrips, but it isn't controlling sitosis. So why is that? I mean, I suspected that it's possibly due to the fact that thripsitosis larvae may be bigger than those of western flower thrips. So as we know, western flower thrips can only eat the little small first stage western flower thrips larvae. Maybe they just can't eat the thripsitosis larvae if they're bigger. Now, I've recently been speaking to somebody from Koppert in the Netherlands, and they're finding that other species of predatory mites, such as Montdorensis and Lamonicus, will feed on thripsitosis larvae, and they are actually recommending Montdorensis on some crops like hydrangea in the Netherlands, and that's giving promising control. So that may be something we need to consider in the UK as well. At the moment, growers who've got the pest are resorting to chemical control in some instances with variable success. We want to get away from that and develop a robust biological program for this species. Now, there are other options. I mean, all these biocontrol agents you can see here can be used for western flower thrips control. So maybe they also have potential for control of sitosis. For example, we have aureus there. Now, that's a predatory bug that will feed on thrips adults as well as the larvae. And I know Herben will be mentioning they've been doing some research on that with sitosis in the Netherlands. Then we have the ground-dwelling predatory mites, such as Hypoaspis, which has now been renamed Stratiolelaps, and there's another species called Macrocheles. They will feed on the ground-dwelling pupae of the thrips. Then we have entomopathogenic nematodes, Steinema feltii, which are also active in the growing media against thrips pupae. We have entomopathogenic fungi, such as Bovaria bassiana, the products Naturalis L or Botanigard. They will have some effect on the adults and the larvae. And finally, we have that little predatory beetle, Apheta, which has now been renamed Delosia, and that will also feed on ground-dwelling stages. So any of these biocontrols may also have potential for control of sitosis. Okay, so what about monitoring? For western flower thrips, traditionally we've used that dark blue colour in the centre because in most conditions that is more attractive to western flower thrips than yellow traps. But we don't know what colour thripsitosis is most attracted to. Koppert tell me that in the Netherlands they don't use traps for monitoring sitosis because they see more on the plants than they do on the traps. And we think that this species is slightly less active in flying than western flower thrips. So maybe they don't get caught on traps as much as western flower thrips do. There's a lot we still need to know. But I do know that in the UK, growers have been seeing sitosis on yellow sticky traps, and Neil Hellier from Fargrow gave me that photograph on the right of where he put little blue strips on the yellow traps, and he says he's been finding more thripsitosis around the edges of the blue on the yellow than on the plain yellow. So there's a lot we still need to know about that really with thripsitosis. Next slide. So western flower thrips isn't just a pest of ornamentals, it can also be a severe pest of strawberry. And a few years ago, our UK strawberry growers were having a lot of problems with western flower thrips before we managed to develop a good, solid biocontrol program using predatory mites and aureus. So at that time, Clare and I were both involved in a big horticulture link project where we were looking at whether we could use these roller traps to trap the adults to help in our IPM programs. We weren't allowed to call it mass trapping at the time because then we would have had to ask CRD to register roller traps as a pesticide, which would be very expensive and time consuming. So we had to call it mass monitoring. So I'm now going to hand you over to Clare to tell you a little bit more about that research and other research he's been doing using trapping techniques for thrips. Thanks, Clare.
Thank you very much, Jude. Yeah, so I want to share with you our general experience of trapping thrips in commercial crops. And I'm going to start again with a little bit of an introduction to thrips, because there are over 6,000 species of thrips, with over 300 in Europe. And they've all got different behaviours, and they've co-evolved with different host plants. And all this important information affects how well they're trapped. And the attraction to traps depends on their host plants and their behaviour. So I've used here, this table summarises some work by William Kirk that he did at Cambridge University back in the day, where he's looked at the attraction of different thrip species to different coloured traps. So you can see, I'm not expecting you to take on the detail of this, but what I wanted to share is, so the top 3 species are all cereal thrips. So their main host is in grasses. And you can see that they're attracted to a wide range of different trap colours. So the trap colours are along the top here. And typically with cereal thrips, you might get an invasion of cereal thrips into your crop around harvest time. So the harvest occurs and then the thrips are in the air, particularly in thunder weather. So I seem to have a bit of an echo, can't do anything about it. And they come into the crop, they don't breed on the crop, and then they move away again. So again, this is something where traps can be particularly useful and important. And as a contrast here, we've got Thripsitosis, which is on plants in the onion family, which is white flowers, and Thrips major, which are originally from rose hosts, again with white flowers, the wild roses. And they're most attracted to the white traps, as you might be expected. White host plants, white flowered, white traps. And that's just to give you a flavour for the different thrips have to be treated differently and they're attracted to different things. For Western flower thrip, as Jude said, you know, the Western flower thrip is most attracted to these sort of darker blue colour with a reflectance in about 420 nanometers wavelength. And in field trials, you can see it quite clearly. You get this best trap catch on this specific colour, but you also get them on yellow and on white. Whereas something like glasshouse whitefly, that's more attracted to yellow traps because they're looking for young, fresh leaves to lay their eggs on because they're leaf feeders. So again, your choice of trap for monitoring may depend partly on what species you want to monitor. So you might choose yellow traps because they're catching both Western flower thrips and whitefly. As we know, as Jude said, Thripsitosis is found on yellow and blue, but do we know their preference and are they attracted to other species? These are to other trap colours. These are all things we need more information on. So if we go nature's never simple, is it? But the light levels also affect attraction to colour. So in our UK conditions, you can get your higher trap catch of Western flower thrips on yellow traps through the winter because it's a little bit of a brighter trap than the blue. And then you can see in this trial from mid-April, the attraction to blue is greater through the summer and in most countries with better light levels. So in crops like cyclamen that you're growing in the winter, you might choose to use yellow traps. Or in light where you've got shaded crops, or if you're placing the traps where perhaps under benches or something where there's less light, your choice of trap colour might be affected, best trap colour. So if we move on from monitoring to mass monitoring, we're looking at different ways of enhancing the trap catch. So at Russell IPM, we've developed the OptiRoll Super, which has got a white pattern on blue traps, and that's typically increases the trap catch of Western flower thrips and rubus thrips by about 25%. So the 3 trials here are showing, it's from different countries, different years, different crops, and we're getting a higher trap catch on the OptiRoll Super with patterns on the trap. We can also increase the trap catch by adding species-specific pheromones. So, for example, Western flower thrips has an aggregation pheromone. This is produced by males and it attracts both males and females. So Western flower thrips, the males have a lek, so it's a bit like grouse in the Scottish hills. They defend an area of territory against other males that females are attracted in to mate. And typically this is an area where they like a bright colour, so it's got to be both visible and have the aggregation pheromone. By adding that, we're typically doubling the trap catch by adding the pheromone of Western flower thrips. But these pheromones are specific, so Western flower thrips pheromone only attracts Western flower thrips. And although many thrip species have pheromones, they haven't all been identified. And until they have, then we are also looking at adding different floral scents to increase the trap catch. So I'm sharing here the results of 2 trials where we've got, one's in a polytunnel, one's in a glass house, both UK, and it was winter conditions actually. So the control is traps without any scents or attractants. Then we've added a flower attractant, then we've added a scent from a pollen, and then we've compared it with Lurum, which is a commercial product that's a Genotrips attractant, that's from Coppert. And the mix there is a mix of the flower and the pollen scents. But you could see that all of these increased the trap catch, and this was mostly Western flower thrips, although there were a few other thrips in there, by about 2 to 3 times. So if you haven't got this species-specific pheromone, you can use other floral scents to increase your trap catch. So can you catch enough thrips to reduce the numbers and the crop damage? So we've been doing many field trials from 2012 to 2020 in various UK crops. And in all these trials, we're getting a reduction in numbers of thrips per flower by 50 to 78%, and in crop damage by 29 to 88%. But I would have to say that most of these trials have been done in crops where they tolerate higher numbers of thrips than in ornamentals. We find with ornamentals, you don't really want to see some crops, you don't want to even see 1 thrips per flower, some crops. So the traps there are more used to maintain the thrips numbers low and prevent a sudden increase than seeing a big reduction in thrips numbers. Now, with all of these, when we're doing mass trapping, we're always combining it with integrated pest management programs. So it's not a treatment on its own, it's something combined with predators and occasional use of pesticides as required. And we're finding that there's a benefit of combining the strategies. So as Jude was mentioning about the predatory mites, typically they're feeding on the larval stage of the thrips, whereas the traps are catching the adults. So you get a better overall control when you combine the predators with the traps. This is to illustrate it, this is an example. It's a strawberry trial where we put the traps up in July. And then by August, you're starting to see an increase in thrips trap numbers in the control plots. The control plots don't have any traps. Whereas where we've got the traps, thrips numbers were slightly lower, or anyway, maintained similar number to the start of the trial. You can see by September, the thrips number have increased up above the damage threshold. So starting to get significant damage in strawberry fruit, whereas the treatments with the traps alone and the traps with pheromone, they would maintain thrips numbers below the damage threshold. And this seeing is believing, so I don't know how well this is showing up on your screens, but it's just to tell you, if you get the right colored trap and the right attractant, you can catch thousands and thousands of thrips. But for some species that are less mobile, like Thripsitosis, we've got to see whether we can catch enough on traps to affect the numbers in the crop. We haven't tested this. So finally, I want to share with you, we are extending this program further. So we had an Innovate UK funding, and we worked with Greenwich University and NIAB EMR. We had a project looking at general repellents and natural enemy attractants. So when plants are attacked, they have their own defense system. So when a pest comes in and there's a mass attack of a plant, they release volatiles, which warns off other pest species, other pests. And it's a range of species, so it's not just thrips, it's whiteflies, aphids, capsids. We're getting a reduction in all of those, a repellency effect on all of those. So when we're looking at whether we can combine this natural enemy attractant and pest repellent, we've developed a product called Magipal with the mass trapping. So we've got the traps there that are attracting the thrips, and we're adding attractants to make them even more attractive. And we're using the Magipal to push the pests away from the crop onto the traps. And this push-pull strategy, here's a commercial crop trial, and you can see again the control is without traps or repellents. Magipal's the repellent, then we've got Optirol's the traps, and then push-pull is combining Magipal with Optirol, and you can see that the push-pull strategy had the lowest thrips numbers right through the season. So we're looking at that for other thrip species and different crops. And so I think you can see that we've got potentially a lot of things, a lot of different traps, colours and attractants and repellents that we could look at as part of an IPM program for these new species of thrips that are coming in. Perhaps we can even invest in identifying the pheromones for them. And back to Jude. Jude?
Jude, do you want to activate your microphone?
Yeah,
sorry
about that.
Sort of say, we are running short of time, and we are now eating into Urban's time. So please, can you be as brief as possible? Sorry.
Yeah, so building on that initial trial on Western flower thrips that Claire mentioned in push-pull, Claire and I are now involved in an AHDB project where we're looking to see if that could have potential against some other thrip species that are causing problems in strawberries, such as the rose thrips, Thrips fuscipennis, which is a native species of thrips, but it's flying in and doing damage to strawberry early in the season before aureus can get established. And because it's an adult, it's not being controlled by the predatory mites. So we're looking at that. We haven't got any results yet, so it's a case of watch this space. Next slide, thank you. So on protected ornamentals, there's a lot we could do. Currently, we don't have any funding to look at these thrip species in the UK, but there's a lot we could do. For example, we really need to know about the biology and behaviour of Thripsitosis on its key host crops. We need to look at how to control it well biologically. As I've mentioned, that the predatory mites Montdorensis and Limonicus look like they are the way forward rather than Cucumeris. There's other biocontrols we could look at. I know Herben is going to mention his work on aureus against Thripsitosis. And we could look at, for example, biopesticides that we could integrate into our programs as well, and possibly a push-pull strategy. So at the moment, I'm doing a review for AHDB over the next couple of months to summarise our current knowledge on the biology and control of Thripsitosis. So if you haven't already spoken to me and you have had problems, please could you contact me? My email address is there. Thank you. And next slide, Claire. So I'd just like to thank you for listening, and thanks to everybody who's helped Claire and I put this presentation together today.
That's great. Thank you, Jude. Thank you, Claire. I need to move straight over to Herben's presentation now. Just I do apologise for the rush, but thank you for that. And just to remind people, if you do have questions, and I'm sure you do for Jude and Claire, there will be a Thrip session at 12:40 at which Jude, Claire will be present. So please join us then in the session to pose questions. So if I can ask Herben to load his presentation up for the second presentation, which was going to be the first. Herben will be talking about thrips, and not all thrips are WFT. Herben is a professor of biological pest control in greenhouse production systems at Wageningen University, and has spent 20 years experiencing and developing control systems for pests such as thrips. So if I can pass on to Herben without further ado for the second presentation in this thrips thing. Thank you, Herben.
Thank you. Do you hear me well?
We can hear you fine, thank you.
Perfect. So I hope things go well with the presentation. Yes, thanks for the invitation to join our experience with thrips control in the Netherlands. I will tell a bit about the different species of thrips we have in greenhouses. So the title of my presentation is also "Not All Thrips is Western Flower Thrips," and I present some results we did together with my colleague Ara Lehmann and Angelos Muratidis. Well, if we speak about thrips in greenhouses, in most cases, we have to deal with Western flower thrips, which is worldwide the most common pest, well known and causing a lot of trouble and damage especially in ornamental industry, in all kinds of cut flowers or plants, but also in vegetables. And we're all familiar with that in greenhouses. And here is a nice picture of the larvae. There might be a little bit of overlap with the previous presentation, but maybe so that I will tell things twice, but hopefully that's only good to get the message. Well, something about the thrips in general. Claire also mentioned it, that there are many thrip species worldwide, more than 5,000 or maybe 6,000 species. And to be aware of that, not all are plant feeding. Some of them are also predators. So the pictures on the bottom, you can see predatory thrips. Some are also fungus feeding. But as far as I know, there are about 160 species in the UK, and in the Netherlands, 135. Might be more in reality, but that's what it's recorded for now. And if we look to the, of course, I'm familiar with the situation in Dutch greenhouses. If I look at the list of species we have, it's already about 12 thrip species that are known as a pest. And also interesting to know is that 9 of them are exotic. So many new species that are entering greenhouses are often imported with plant materials, and they somehow establish in the greenhouses. Well, with all this diversity in thrip species, I think it's important to recognize the thrips. Jude and Clare were also mentioning this already. It's important to know the biology and also the behavior of these species. Well, how to recognize the thrips? Well, there are all kinds of characteristics, morphological, like the antenna, how many segments on the antenna, or how the wings look like, and all kinds of specific things. And I think, well, we attempted to develop a kind of identification poster, which is also available online, a kind of tool to help you to identify the thrip species you can have in your crop. And this is about 14 species you can find, and it has actually 2 steps. One step is just how it looks like in general, so to get an idea. And if you want to go in more detail, you need actually microscopic slides. You can also identify up to species level what kind of pests you have, or thrips. Well, what if you look at this poster, then I already told that 9 of them are exotic, and it's those thrips enter greenhouses mostly through transports of plant material. And for example, Western flower thrips entered the Netherlands in 1983, so in the 80s. And if you look how this thrips species spread all over Europe, so it started in the Netherlands, but it was imported from the United States. So in the Netherlands, we also call it the Californian Thrips, because it came from California. And now it's spread all over Europe and actually all over the world. Also, for example, in Africa, where this thrip species is not indigenous, in Kenya and Ethiopia, where they grow cut flowers, they also now have Western flower thrips. So somehow it was also transported with plant material to those areas. So, and this is something we observe with all kinds of thrip species. So we can, for that reason, also expect, I think coming years, maybe also more new species that can be damaging. So Jude already told a lot about the Japanese flower thrips. It looks beautiful, but it can cause a lot of damage. It was found the first time in hydrangeas. And you can see here the damage on the leaves and the larvae. And yeah, this species came from Asia, Japan, South Korea. And in those countries, it was not really known as a major pest. But yeah, once it arrives in the greenhouses, it can also be found on new host plants, plants what we did not know before that were host plants, and they can cause some serious damage. Yeah, there is a discussion about the pollen feeding. I think it's important to know Western flower thrips really feeds on pollen. So if you also provide pollen, for example, to support predatory mites, you have to know that if this food source is also a food source for the thrips. Well, for Western flower thrips we know, but for Thripsitosis, in our trials we did not see any benefit for the reproduction of Thripsitosis. But that might depend also on the crop and the type of pollen you provide. Well, another species already present for quite some years is Genotrips Americanas. Actually, I don't know if this is a problem in the UK. It can cause a lot of damage in roses, pepper. Here are the larvae. But this one is also increasingly causing problems now because of the reduction of pesticides. And again, here you see the same story that it came, it is spread all over Europe through the Netherlands by transplanting plants. And in this case, Dieffenbachia played a major role. Okay, and also this pest, we see now that new crops appear to be a good host, like hop or cannabis grown in greenhouses. Genotrips is causing a lot of damage and problems. And with what it's important to know your thrip species, because not every thrips is a suitable prey for every natural enemy. Jude was mentioning this already. We, for example, also did studies with Genotrips and 4 species of predatory mites, and this is the daily consumption. Well, in this case, Amblydromalis limonicus was doing quite well, but if you look at the reproduction of the predatory mites, limonicus was doing much better than the other predatory mites. So it's not only the consumption, but also how well a natural enemy can reproduce on the pest is important for control. So another argument to why it's important to know which thrip species you have. Well, another example, the orchid thrips we already have for many years, but also here there's still much we do not know. And recently we have since last year in Dutch greenhouses a lot of problems with tobacco thrips, and we call it actually the pepper thrips, Thrips parvispinus. It came from Asia, gives a lot of damage in countries like Indonesia and pepper. But if you look at the literature, there's hardly anything known. So since 2019, it was found on Ficus, Gerbera, Schlafera, and there were some previous reports from Spain and France. But because it's already established and you can find it everywhere, there's no possibility anymore to eliminate it or control it completely. It's more or less established. So for that reason, it did not get the quarantine status. And very little is known. So also for this thrip species, we need to understand the behavior and study how to control it and see what's different from other thrip species. Well, there's always also the discussion about thrips, what's coming from outside. And we did a small study in the Westland, in the western part of the Netherlands, where you can see the whole greenhouse industry, many greenhouses. And on the red spot, we took samples to see what kind of thrips is present. And because there's also a big discussion going on about the role of biodiversity. Well, we want to implement more biodiversity also around greenhouses, but actually most growers prefer the short lawn management. And so the discussion is what is the risk of this biodiversity for thrips? Well, just to give you an impression, there are many thrip species you can find outside, and many of them we actually do not know whether they are pests. At least they are not known as pests. And what we found outside, that we identified more than 10,000 species, and from that this whole group, only 5% was Franchinella occidentalis. So outside you can find low numbers, and probably they just first came out of the greenhouse and developed outside, and then you can find low numbers. But there are also some species that can cause some damage, like Thrips tabaci and Franchinella intonsa, for example. But there are also many species you can find that are not known as pests. So this is good to realize. So this is, for example, Thrips tabaci that can give a lot of damage in leek, onion, and yeah, it's good to know that to identify the thrips. And sometimes you have this huge influx of mass flights. Clare was mentioning this already. Sometimes they're also called thunder thrips, and in most cases these are crane thrips that do not reproduce on greenhouse crops, and so they're not actually known as pests. But at the end of the cropping cycle, you can have these massive flights, and you can find them in high numbers also in your greenhouse. So this is good to know. Well, something about biocontrol. Yeah, we have all those new thrip species, and yeah, also in our case, we hardly know anything about the control. So there's still a lot to study. And one of our PhD students, Angelos Muratidis, is working on aureus and the control of different thrip species. And he started to do simple observations to see whether they're able to attack them and predate on them. And already there, he found some interesting differences between the thrip species. And if you actually it's good news, because if you compare here in these bars, you can see the percentage of successful encounters. So when they are able to attack the thrips and predate on them, and then you can see that in the red bars represent Western flower thrips, that the number of attacks that are successful are quite low. And the new thrip species, Thripsitosis and the Genotrips, they are quite more successful. So this is good news for aureus. But we have to realize that aureus also, how well aureus establishes in a crop really depends also on the crop. So that's another aspect you have to look at, how to establish aureus populations in ornamental crops. But this looks promising, and also interesting differences.
Herben, can I just, sorry to interrupt, can I just sort of say we've got about 3 minutes to finish off? Sorry.
Yeah, I'm finishing. Yes, this is my last slide, actually.
Thank you. Sorry.
Yeah, so this is just to give you a kind of overview what kind of thrips we have, and I would like to summarize with 7 reasons why knowing and recognizing your thrips is important, because there are all kind of differences. And for example, in the distribution patterns, how well they distribute in your crop. Some are very patchy, some are more equally distributed, and this is important for how to control them. And also in the plant, you see differences, which parts of the plant they prefer. Some are in Western flower thrips, immediately close to the flowers, and others are more on the leaves. Some are on older leaves, some are on younger leaves. Important to know. Whether they feed on pollen or not is important. Also, if you want to use pollen as an alternative or supplemental food source for natural enemies. We see differences, and we know there are huge differences in how vulnerable they are for pesticides and pesticide resistance. And we see differences in predatory mites. Not every thrip species is suitable for every predatory mite species. Important to know. Not every thrips is a pest, and also not every thrip species transmits viruses. So this is, if they do, it's an extra concern, of course. So all kind of reasons to why it's important to know your thrip species, and and I think we should also try to increase our knowledge about these thrip species, and Also good to hear that Jude will start a new project to get more information. And also in the Netherlands, we have started a new project this year because the number of new Thrip species has really increased last years. And we also would like to work on basic biology and explore options for biological control, and also work on push-pull strategies or combinations of treatments. And at the end, I think in many cases you need to look at combinations. There's never, and almost never, one golden bullet, but you need to combine treatments to develop effective control strategies. So that's more or less my presentation. Thanks for your attention. And actually, I don't know if there's time for questions.
Unfortunately, Herben, no. We've got the next speakers being lined up as we talk at the moment. But thank you for that. I do appreciate you're unable to attend the session, but apparently you have a colleague who may be able to join us and take questions in the session at 12:40.
Yes.
That'd be fantastic if that is the case. So just to remind everybody, please join us at 12:40 in the Thrips theme session if you wish to pose a question. And also just to mention that the Thrips poster that Herben did show earlier on is available to download in that particular session. We did work with Herben to translate that into English. So if you don't have a copy, it is available then. So thank you to all our speakers, Herben, Jude, and Claire. And thank you, and I'll bring this session on Thrips to a close. Thank you.
Yes. All right.